Hello everybody, this is Carmen Killed the Cat, and welcome to your 9th Lua tutorial. In this tutorial, we will be going over metatables and object-oriented programming. So if you don't know what object-oriented programming is, it's when you create a prototype of an object, and then you can create different instances of that object that will exist completely separately from each other, and they can interact with each other, but they are completely separate. And most languages, like C++ and Java, provide things like classes and structures to kind of make object-oriented programming easier, but in Lua you have to make your own objects, and we do that with tables. And what metatables are is, if you're familiar with C++ operator overloading, it's kind of like that. You just change how a table or an object behaves when it's given a specific operator, like the plus, minus, subtract, and things like that. So let's get started. So we're going to be using an example in this tutorial. We're going to use a vector3, which is used in graphics programming. It's a vector of 3 members, the x, y, and z, which are the 3 axes in 3D programming. So we're going to say vector3 equals x, x equals 0, y equals 0, and z equals 0. So that's the first table. We're going to be creating 3. Now we're going to create vector3.prototype. So, don't worry about what this one does yet, but we're just gonna make it a copy of this table. So the same thing. Now we're gonna create vector3.empty, and we're gonna make this an empty table. So this is the prototype of our vector3 class. So it'll have an x, y, and z member, and it'll also have some functions in it that we'll define in a minute. This is the prototype. This is used for one of the metatables. Don't worry about this yet. And this is the table that stores all of vector3's metatables, so don't worry about this yet either. So now let's create some functions for our table. The first one we're going to make is the equivalent of a constructor in any programming languages that has predefined classes. So if you don't know what a constructor is, it's a function that's automatically called when you create a new instance of a class or a structure. So we'll call this vector3.new, and we'll make it equal to function and empty parameters. So in the function, we'll create a local variable called vec, and we'll set it to an empty table. And now we're going to call a new function. It's a predefined function in Lua. It's called setMetatable. And what it does is it binds a metatable, so we're going to use vector3.mt for vector3.metatable, and we're going to bind it to this vec table. So let's call it setMetatable, and the first parameter will be vec, and the second will be vector3.mt. So I'll explain what metatables are when we get to that part of the tutorial, but just know that this binds a metatable to a table. So now we're going to introduce a new kind of for loop. I'll probably have a separate tutorial for this in the future, but if you just use it this specific way for now, it will still be pretty helpful. So we'll say for k, comma v in, and then we'll say pairs vector3. And do. And we'll put the end statement here. So this is a special for loop. C# has something very similar to this. It's just a special for loop that loops through a table, even if it has named indexes like this, instead of just numbered. So for kv in pairs do, and we'll say vec at position k, and k means key, so the key, which would be the x, y, and z. So vec at position k, this is another way. You could also do vec.k. It means the same thing. So vec at position k equals v. And v is the value, so it would just be 0, 0, and 0. So now we've created a local vector and set it to a table, and we've binded the metatable of that table to vector3's metatable, and then we've set all the values in this new table to match vector3's initial values. So now we just need to return this. So we'll return vec. And so to use this, what you'll do is you'll say v1 equals vector3 dot new. And there's no parameters. So now let's just print v1 dot x, v1 dot y, and v1 dot z. So if we print this, we get 0, 0, 0. So that's what we'll call the constructor for our class. So now we already have an object that can be created with separate instances. So let's say v2 equals vector3.new. So now this creates two separate instances of the vector3 class, and we can say v1.x equals 10, and then again we can print v1.x, v1.y, and v1.z. So now it says 10, 0, 0. So the x member of v1 was changed to 10. But if we do the same thing for v2, 2.y, and v2.z. So now if we print both of these, we have 10, 0, 0, and 0, 0, 0. So only vector 1's x member was changed to 10. Vector 2's x member is completely separate from vector 1's, so it stays at 0. So that's really the basics of object-oriented programming. So now let's add some more functions to the vector3 class. Now we could say vector3.add, and then we could create a function like this. So vector3.add equals function, and then we'll say we need v1 and v2 and end. So let's create a function that adds the two vectors together. So we'll say v1, or no, let's create another local vec. Local vec equals empty table, or actually no, it has to be vector3.new. So we're creating a new local instance of the vec, and now we're saying vec.x equals v1.x plus v2.x. And then we do the same thing for the y and z members of x, or vec. Oops. Sorry about that. Forgot I didn't hit C. So we just copy this twice and change this to y and change this to z. And then we just return vec. So now we have a function that adds the two vectors together. So let's just recreate this. We'll say v1 equals vector3.new. I should have just kept this. I shouldn't have deleted it. And then v2 equals vector3.new. And now let's say v1.x equals 10, v1.y equals 20, and v1.z equals 30. And then we'll do the same thing for v2. v2, and v2, and we'll just give these different values. We'll say 40, 50, and 60. I don't know why that deleted itself. 50 and 60. So now let's say v1 equals v1.add and v1 v2. And now let's print all the members of v1 again. So print v1.x, v1.y, and v1.z. So what we're doing here is we're creating two vector3's again, and then we're setting all the values of one, and then we're setting all the values of the other, and then we're adding them together. So if we run this, it'll print 50, 70, 90. 10 plus 40 is 50, 20 plus 50 is 70, and 30 plus 60 is 90. So that worked. But there's actually an easier way to do this. So let's get rid of just this line. The rest of this will stay for the rest of the tutorial. So instead of creating a separate function for add, we can use metatables. So to change this from a normal function to a metatable, it's pretty simple. Instead of just doing vector3.add, we do vector3.mt.__add. The name must be __add or this won't work. So we keep the function exactly the same, but now it's simplified, so we can do v1 equals v1 plus v2, and this will give us the exact same results as the last function. So 50, 70, 90, just like before. So that's what a metatable is. It is a function that can change what happens when you use an operator like the plus operator on two tables. So there are a bunch of different metatables, and I'm not going to create functions for all of them, but I'll list them all for you, and you should be able to figure out what they all do. So there's obviously __add, and then there's __sub, and this does the same thing, except for instead of the addition operator, it does it for the subtraction operator. There's also __mul, and same thing but for the multiplication operator. And then there's div for the division operator, not dev, div for the division operator. There is mod for the modulus operator. There is pow for the to the power of operator. And those are all the arithmetic ones. There are also comparison operators, and I will create a function for the less than operator. For less than, it's __lt. For less than or equals to, it's __le. For the two equal signs in a row, there's no just one equal sign metatable. It's __eq. And there's no greater than or equal to ones, because saying A is greater than B is the same thing as saying B is less than A. So Lua doesn't have greater than or equal to operators. And then there's also __index, which I'll go over, and __new index. And these are different. I'll go over these later. I'm not going to explain them yet. So now let's create a function for the less than metatable. Oh, and just to prove that you need to have a metatable to use these operators on tables, let's comment this out and see what happens. Lua, x.lua, error at 41, attempt to perform arithmetic on global v1, a table value. So without a metatable, you can't add two tables together. And that's what vector3 is. It's a table, even though we're using it as a class. So let's put this back together, and it will work just fine. So now let's create a function for the less than operator. So this is going to be a pretty small function. vector3.mt.__lt equals function. We do need parameters. v1, comma, v2. And end. So this is going to be a very small function. We're going to do return v1.x is less than v2.x, and v1.y is less than v2.y, and v1.z is less than v2.z. And this line might be confusing, but if you don't know the comparison operators, this just returns a Boolean value. So if v1.x is less than v2.x, then it returns true. Otherwise, it returns false. And then we just use the and to combine them together so that they all have to be true in order for the function to actually return true. Otherwise, it will return false. It's the same thing as saying if, and then all of this equals true, then return true, else return false. So this is just a shorter way of saying that. So now, let's print v1, we need parentheses, v1 is less than v2. And this should return true. False. 1 second. Oh, very stupid mistake. I forgot to do this. So now it should work. v1 is less than v2 because v1.x is less than v2.x, v1.y is less than v2.y, and v1.z is less than v2.z. And it didn't work before because I had v1 equal to v1 plus v2, so obviously v1 plus v2 is greater than just v2. So now it works, and if we switch these around, so v2 is less than v1, that's false because 40 is greater than 10, 50 is greater than 20, and 60 is greater than 30. So that's the less than metatable. So you should be able to figure out how to write the LE and EQ metatables. For LE, you just replace the operators with less than or equal to, and for EQ, you just replace them with the equals to operator. So let's just replace this, and now we'll go on to the underscore index metatable. So what this one does is, in the earlier table tutorial, the basic tables, I think I said that when you try to access a position in the table that doesn't exist yet, then that will just return nil. And that's true, but the underscore index metatable can change that. So let's write the function. One sec. vector3.mt index. And this is what the vector3.prototype table is for. And equals function. The function takes two parameters. The table that was accessed, but we don't need that, so we're just going to put an underscore to show that we don't want it. Depending on what function you're writing for the index metatable, you may actually need this, so don't always just put underscore. And remember that this is the table that was accessed. And then we'll have key. This is the key of the table that was accessed. So say here it's z. That's the key. So what this function kind of is it's the replacement for this for loop, the generic for loop. That's what this is called in the new. So we can actually get rid of this. So now we don't have any generic for loops that don't really make sense to you yet. I will do a tutorial on those later, but not now. So for this, we're going to say if prototype at position key. So if prototype at position key does not equal nil, then, and it needs to be vector3.prototype. Vector3.prototype. I can't type today. So if vector3.prototype at position key does not equal nil, then we return vector3.prototype at position key. And then we're going to say else. So if the value does not exist in this prototype table, which is the exact same as this table, then we're going to say we're going to use the error function that's predefined in Lua. This just creates an error and outputs it to the output screen here. So we're going to say error key, and we use this operator to combine key with a string, and then space is not a member of vector3. So again, what this function is doing is it's checking if the value that we try to access, so in this case it would be v1.x, we're checking if that exists in vector3.prototype. So x does exist, so then we're going to return vector3 at position prototype, or vector3.prototype at position key. So this is a replacement to the generic for loop where we set all the values in vector3 to the prototype. In the index metatable, this just does it for us without the for loop. And it also only does it when we need it, so say we never use the z member, then that's just memory that's not wasted. And then the else statement, so if the member trying to access is not part of the vector3.prototype table, then it's just going to output an error. So let's run this, and end oh, I forgot to put an end here. Now it should work. So 10, 20, 30. So it works fine. So now if we comment out the index metatable, this is a multi-line comment. You have the comment, and then you have two square brackets, and then you end it with two square brackets going the other way. So now let's say we try to print v1.x, v1.y and v1.z. Then we run this, and we get nil, nil, nil. That's because we don't have the index metatable to say that when we try to access this and it doesn't exist yet, then you should just make it the prototype from vector 3. So now if we uncomment this out, then we get 0, 0, 0, 10, 20, 30. So that's the underscore underscore index metatable. So the final metatable that we're going to go over today is the new index metatable. So what this does is this lets you choose what happens when you try to change a value in the table. So for the example here, I'm just going to write a function that creates an error whenever you try to change the value of the table. You can create something different if you want. You can say make it so the vector 3 can only accept numbers. So if you want to do that, that would be what you would use. That's the function to check the type of a variable. So that's what you can do if you want to do that. So I'm going to say vector3.mt dot underscore underscore new index equals function, and this has to take 3 parameters. So the table that has the value that's being changed, the key of the value that's being changed, and the value that it's being changed to, and then we'll end. So again, I'm just going to write a simple function that creates an error whenever we try to change anything in the table to make it a read-only table. So error, this is a read-only table. So now if we run this, we get an error. This is a read-only table. And I don't know if I actually tested out the new index thing. So for the error part of new index, we'll say v1.w, and we can get rid of this. So v1.w, w is not a member of vector 3, in case I forgot to test that out. And then we'll put this back in. So yeah, we get error. This is a read-only table. So that's the last metatable we're going to go over in this tutorial. There is actually one more called underscore underscore mode, and that's for memory management, but we'll get into that in a later tutorial. It's a bit more of an advanced topic. So I'm not sure what we're going to do in the next tutorial. Could be that. So see you in the next tutorial.